All right, dude, we are live. What's up, guys? This is Dem Keys, and we are live. I mean, I don't want to say for the second time today because I just had to restart this stream after being live for like maybe 30 seconds or 1 minute because I messed up the entire like beginning of the stream because like I messed up something because of which things started going so. Anyways, so what's up, guys? This is Dem Keys, and today we're going to be continuing our Kaggle studies. We're going to be continuing learning machine learning. More specifically, we're going to be learning about underfitting and overfitting. So in the previous stream, we got done learning how to use decision trees and decision tree regression through scikit-learn in order to make predictions on housing prices. And I still have a bunch of research to do on decision tree regression. After the last stream, I started doing more research on it. I had a conversation with Gemini. Actually, I think I had the conversation. Where did I have the conversation? Hold on. I'm trying to remember if it was on the other machine or if it was on this machine that I'm streaming for. I think it was on this machine. Hold on, let me see if I can show it to you guys. We're not going to be doing that. Like we're not going to be looking at that during this stream. Um, yeah, it might show up here. Yeah, it should show up here. So let me just. I think this is it. Yeah, this is it. This is the conversation that I was having, where I was trying to get a better understanding of decision tree regressor, but I first wanted to understand what decision trees are and how they work, and then also the concept of regression, which turns out in this case regression is basically just predicting a continuous value. Which I need to have a conversation with Gemini about this as well. That why is it called regression? When we are predicting a continuous value? What exactly does regression mean here? And how did that term come about? But that's for a later time. For now, I'm focusing on trying to understand decision tree regression and how exactly this algorithm is working, because the I understand the concept of it on a much higher level, where it's like, okay, this is basically a decision tree. It asks a bunch of questions. It creates a tree that's asking a bunch of questions regarding the various features that are present, and based on that, based on the responses to those questions, it will pick a prediction or somewhere in a range of a prediction. That's what I've understood, like on a conceptual level, that okay, yeah, this is our tree, and this is how the tree structure flows. But I don't really understand how exactly that tree is being formed, how exactly the questions are being asked, how the model knows what questions to ask, how the model knows how to relate the various features with each other, and all of those questions are going to be answered through my research through Gemini. We are not going to be doing that on stream though. We're going to be focusing on overfitting and underfitting. Give me a second. Let me go back here. Uh, what was this conversation I was having? This was about DuckDB and SQLite, and oh yeah, this was a conversation I was having regarding every now and then I have this conversation with Gemini where I try to catch up on database technologies, because the last time I used like properly used database technologies was more than a decade ago, and that was using SQL Server. And yeah, that was a completely different system. That was nothing like what we have these days. And back in those days, and this is like I'm saying a decade, but it was more than a decade. It was more than a decade ago. Probably a decade and a half, I would say. So since then, like I haven't really touched database technologies all that much because I didn't need them. At least for the stuff that I was doing, I didn't need them. So I didn't really pay much attention to database technologies. And so now I'm trying to catch up on it because now I can actually use it. And even if I don't use it, I kind of want to know about it because especially when you're doing ML stuff, when you start doing it in like a professional capacity, you're not always going to be storing things in files. There are quite often times where data is stored in databases. It's written to and retrieved from databases, be it a database that's hosted somewhere on a server or a database that's in process, which is interesting because like this the in process part, the in process aspect, is something that I learned about through doing this research. I didn't really know that this is also a thing. Like now we now have actually not now. It's probably been there for more than a decade, but yeah, we have these. Now we have tech where I'm saying now, but it's like now I shouldn't say now. It's been there for a while. I know about it now. That we have tech where you can start up a very small, lightweight database engine to host the database, and all of this is running within the same process from which you spawn that database engine. So you can have this database engine running there, and then you can use it to um, you can load your database in it, and you can store stuff in the database. You can retrieve stuff from the database, and once you're done with it, you can just clear it all up and close the application. You don't have to have the database hosted as a separate server. So I want to learn. I want to learn more about this. Wait, I didn't realize that the window that I'm showing you guys is what I'm using for the what do you this is the window that I'm using for the matrix rain. I forgot that that's what I was doing. But yeah, hopefully you guys got an idea of what I was trying to show. This is the conversation I've been having. This conversation, I believe this came about because I was trying to install a database viewer called Frog Rain, I think it was called. Yeah, I think it's called Frog Rain. It's a database viewer that supports various database backends. And while I was installing this, there was something that took like ages to install or well build. Because I think this was a Rust-based application, and so all of the crates and stuff that I use, they also get built when you're trying to install the application. And it took ages to build. I believe it was DuckDB. I don't remember exactly, but there was one crate that was taking like ages to build, and because of that, my CPU was going into like it was like at high CPU usage for a very extended period of time because yeah, that was it was either yeah, no, it was probably taking time to build. I'm trying to remember if it was also a massive download, but I don't think it was. It was just taking ages to build. So that's kind of what got me doing research on this. I was like, dude, why is this taking so long? What's going on? And then Gemini told me, about it. And then I started asking questions about other stuff, database related. And then eventually I came back to this question, which I ask every now and then to Gemini, which is, tell me about the currently in use database tech. And yeah, here we are. So we're gonna before I get way too sidetracked, we're gonna continue. Give me a second here. By the way, shout out to Egopath. We rated Egopath the last time that I streamed, which was maybe the day before yesterday. I think so. And Ego was using this application called Wiggly Paint, and I did some research on it. Apparently, it's built on another application called Decker, and you guys should really check out Decker. Dude, Decker is something that I feel like solves a bunch of problems. It's one application that's a very lightweight, like incredibly lightweight application that solves a bunch of different problems when it comes to, let's say you want something to sketch out real quick, or if you want to do quick presentations, or if you want to even build like a very small, it doesn't even have to be small, a very simple or simple looking interactive experience, or anything like multimedia related. If you want something, if you want a simple toolkit, simple yet sophisticated, sophisticated toolkit that can do quite a bit of things, you should definitely check out Decker. I would absolutely recommend checking out Decker, and I've tried it out on Linux. You guys can try it out on Windows. I'm sure it'll work on Windows as well. On Linux also, it wasn't heavy at all. Like, I opened it up and there was barely any CPU usage, and there's quite a bit that you can do with it. You can do you can do like simple sketching, but you can also use animated brushes or animated strokes. So the strokes have certain types of uh, dynamicism to them. They have like some movement going. They're animated to a certain extent. So when you paint with them, whatever you've just painted is gonna be, it's gonna have like animated stuff going on. You can also create UI components, buttons, sliders, text boxes, and stuff. And you can also program them to do stuff. So this is how you can make an interactive multimedia experience, which is incredibly useful for so many different use cases. Like, dude, this is incredibly useful. This is like imagine you need to make a PowerPoint presentation which has a bunch of, which is more focused on the information and less focused on aesthetics. So if you're trying to just give information and you want it to be in a presentation form, or you want to be able to demonstrate things, or whatever, dude, Decker is so useful. It is incredibly useful. I also found out that apparently the name Decker comes because the application presents each of the canvases that you draw on. It presents them as cards, and they're kind of like stacked on each other, and so that's a deck of cards. So I mean, dude, I was impressed by this incredibly simple yet sophisticated, and incredibly useful yet also very lightweight application. Dude, I can see myself using this application at some point in the future. I'm wondering I'm wondering if I would be able to run the exported stuff on on ESP32. I should look into that because I remember it being mentioned that you can export whatever you are building as an HTML file, and the entire experience will be exported as one HTML file. I don't remember the one part, but I believe it said it's one HTML file, one self-contained HTML file, with like, I don't know if there are any external dependencies, or if everything just gets built into that one file, but it did. I remember it saying one file, but like I can't remember for sure. But yeah, they did say that you can export this as an HTML file, and then you can run it in the browser, just as you would be running it within Decker itself. So, keeping that in mind, I wonder if, keeping that in mind and considering that this is a very mature open source application that is widely used by many people, I'm wondering if people have worked on tech to be able to export this into a form that can be run by the ESP32. I should look into that to see if we can set something like that up, because that would be great. That would actually be great to set up UI and stuff within an ESP32, or even just set up simple images, simple animated stuff within the ESP32. But yeah, okay. Let's not get too distracted here. We are supposed to be learning overfitting and underfitting. Let me open up my stream manager. Give me a second here. Okay. How long have we been live so far? Okay, it's only been around 15 minutes. Good. So, give me a second. Let me just take a sip of water and then I can start reading. So, like I mentioned before, I'm not done. Actually, let me finish. Let me let me drink some water. Hold on. Okay. Uh, what was I saying? Yeah. Like I mentioned before, I am not done with decision tree regression. I want to understand the tech properly before I move on too much further. But I also don't want to hold back my progress when it comes to when it comes to when it comes to doing these courses in Kaggle. I don't want to get like hung up on one specific algorithm. Um, I need to keep reminding myself that yeah, I don't want that to happen, because I feel like that has happened with me. That happened with me at least once, but I think more than once. It has happened where I kind of got too hung up on the algorithm and didn't progress. Fortunately, they've presented these chapters. They've fortunately they've set this up as a bunch of courses, right? So each of these chapters, it kind of reminds me that, oh, I need to keep progressing. I need to keep moving further. I shouldn't get too hung up on that, or I'm not going to finish the course. It's kind of weird thinking of it in that way, that I'm just moving forward just so that I can finish the course. But I kind of have to think of it in that way to stop myself from getting too hung up on the thing. But at the same time, I also want to get hung up on it a little bit just so I can put more effort into understanding the thing. So in the future, if I ever need it, I can use it. That being said, I think start when I start doing like exploratory data analysis, and when I participate in more Kaggle competitions, I think I would be using these models more anyways. So I feel like then I would get a decent understanding of them. Yeah. That being said, read. Let's start reading about underfitting and overfitting. Okay. At the end of this step, you will understand the concepts of underfitting and overfitting, and you'll be happy. Where did I read happy? I think I read apply and thought happy. And you will be able to apply these ideas to make your models more accurate. Okay. Experimenting with different models. Now that you have a reliable way to measure model accuracy, you can experiment with alternative models to see which gives the best predictions. But what alternatives do you have for models? You can see in scikit-learn's documentation that decision tree um, Where was I? Here. That the decision tree model has many options, more than you want or need for a long time. The most important options determine the tree's depth. Okay. Recall from the first lesson in this course that a tree's depth is a measure of how many splits it makes before coming to a prediction. I actually don't remember that. I think I missed that part in the theory, or maybe I read it and just forgot. But yeah, okay. Or maybe I'd understood this concept in just a different way. Anyways, this is a relatively shallow tree. Okay, so this is our shallow tree. Then, in practice, it's not uncommon for a tree to have 10 splits between the top level, which is all houses, and a leaf. As the tree gets deeper, the dataset gets sliced up into leaves with fewer houses. See, this is what I've been trying to understand. This is one of the reasons why I've been trying to understand how exactly the decision tree regressor works, because I've been trying to get an idea of how it's asking the questions, on what basis it's asking the questions. At some point, I think I want to be able to visualize the tree. I think that's a good idea. If I'm able to, then I do want to be able to visualize the tree. That just occurred to me. I want to be able to visualize the tree if at all it is possible, because it so the thing is being um internally it's being represented as a tree, but I don't know if that representation is necessarily meant to be visualized. Maybe its representation is best used for computation, but I don't know if it's something that's easily visualized. That would be something interesting to look into, though, because being able to visualize what exactly this decision tree looks like, it's going to give us an idea of what this tree is learning, and more importantly, how the tree is learning. Where was I? Okay, if a tree only had one split, it divides the data into two groups. Okay, yeah, where was I? Yeah, if a tree only had one split, it divides the data into two groups. If each group is split again, we would get four groups of houses. All right. Splitting each of those again would create eight groups. If we keep doubling the number of groups by adding more splits at each level, we'll have 2 to the power 10 groups of houses by the time we get to the 10th level. That's 1024 leaves. Okay, when we divide, hold on, yeah. When we divide the houses amongst many leaves, hold on. When we divide the houses amongst many leaves, we also have fewer houses in each leaf. Wait, really? When we divide the houses amongst many leaves, we also have fewer houses in each leaf. Okay. Leaves with very few houses will make predictions that are quite close to those homes' actual values. Leaves with very few. See, at this point, I'm having trouble visualizing what's going on here. But okay, let's continue reading. Leaves with leaves with very few houses will make predictions that are quite close to those homes' actual values. But they may make very unreliable predictions for new data because each prediction is based on only a few houses. This is a phenomenon called overfitting, where a model matches the training data set almost perfectly, but does poorly in validation and other new data. Okay, so basically, it's not able to generalize very well on newer data. It basically it sticks a lot to its own training data. And so anything that's similar to its own training data, anything that has features that are more similar to its own training data, it'll give you a more accurate prediction for that. But something that's deviating quite a bit from the training data, you're not really going to get an accurate prediction. You'll get like a best guess. Okay, where was I? Yeah, but does poorly in validation on other new data. On the flip side, if we make our tree very shallow, it doesn't divide up the houses into very distinct groups. At an extreme, if a tree divides houses into only two or four, each group still has a wide variety of houses. Resulting predictions may be far off for most houses, even in the training data, and it'll be bad in validation too for the same reason. It'll be bad in validation for the same reason. Validation is just testing, right? Like you're testing the accuracy of a trained model. I think so. Anyways, when a model fails to capture important distinctions and patterns in the data, so it performs poorly even in training data, that is called underfitting. Okay. Since we care about accuracy on new data, which we estimate from our validation data, we want to find the sweet spot between underfitting and overfitting. Visually, we want the low point of the validation curve. We want the low point. Okay, so what are we looking at here? The error. So the error starts to reduce as the tree depth, as the tree becomes more deeper, but then past a certain point, the error increases. But then during training, it might still look like the error is, constantly decreasing. Okay, okay. All right, visualize the this is a good way to evaluate. That's what I was looking that's what I was looking for. This is a good way to evaluate the accuracy of the model. Okay. All right. Example. There are a few alternatives for controlling the tree depth. Just a second. Let me scroll down here as well because I am reading it off of a different screen. Okay. There are a few alternatives for controlling tree depth, and many allow for some routes through the tree to have greater depth than other routes. But the max leaf nodes argument provides a very sensible way to control overfitting versus underfitting. The more leaves we allow the model to make, the more we move from the underfitting area in the above graph to the overfitting area. All right. We can use a utility function to help compare mean absolute error scores from different values of max leaf nodes. We can use a we can use a we can use a utility function. Holy shit! Why is that so hard to say? We can use a utility function to help compare MAE scores. Oh, we are defining the function ourselves. Okay, right. So model, create the model, fit the model, and then predict, and then do this. Oh, okay. That's how we're doing. So we are running multiple. Okay. All right. We can test this out right now because we do. Um, were we doing it here? I think it was here. So what were we doing here? Yeah, we did the same thing here as well. Which, I mean, I guess we could do this for either one of them. Yeah, I guess we could do this for either one of them. It's not gonna make too much of a difference. And I've done a bunch here. Um, which one should I go for? Okay, let's go for this one. All right. So we need from sklearn dot metrics import mean absolute error. And then here, let's define a function. What is it? Def get underscore MAE. What does the thing look like? Yeah, max leaf nodes. And then we have to pass in train X and val X, and then train Y and val Y. Okay, so then we create the model, decision tree regressor, and here we want to specify max leaf nodes equals max leaf nodes, and also a random state equals 1. So that's our model. Then we fit the model with the training data. So that's train X and train Y. That is not supposed to be a tuple, so let's get rid of that. Okay, awesome. Hold on, there's something I'm curious about here because I deal with this often. This window, how? Oh, like that. Well, that gets rid of that moves it out of yeah, I need to find a way to get rid of this window if I ever need to. Um, oh, that's a good way. That's a good way to do it. Okay, right. Give me a second here. Awesome. So, right, we are doing train Y. Okay. After that, we want to get the prediction. We store the prediction value here, and we do model dot predict val x. Okay. And then MAE equals mean absolute error, where we pass in the true prediction or the true value and our predicted value, which is preds val. And then we return. I'm curious about why it's being returned as this, like in in brackets, in parentheses. But I mean, let's do it anyways. Yeah, I don't see why we are returning the thing in parentheses. The data is loaded into train X, val X, train Y, and val Y. Okay. Using the code you've already seen, just a second. Using the code you've already seen and which you've already written. What is this? Oh, this is the code. Oh, okay. This was supposed to be done on the Melbourne housing data thing. You know what? We can do that. We can remove it from here and put it here instead. Great. Awesome. Give me a second here. Let me just hydrate and then we can continue reading. Okay. All right. Um, where was I? Right. So this is our code. Now, at what point do we start calling get May? I'm also curious about how we're going to be displaying. Oh, this is how we're displaying it. I was wondering if we're going to be displaying it as a graph, but that's yeah, we're not doing that. So this might take some time if I'm doing this on my system, but that's okay. Now here, once we get this data, I don't think we need this. So real quick, we can just comment this out. And then here we can create this for loop for max leaf nodes in 550, 500, and 5000. We say my May equals get May, and then here we want to pass in max leaf. Now, what's the, okay, max leaf nodes, train X, val X, train Y, val Y. Okay, max leaf nodes, then train X, val X, train Y, and val Y. And then we want to print out, what's this? Okay, so this is doing it in a different format than what I'm used to, but let me just try to understand what it's doing, and then I can use like a formatted string to do it. Max leaf nodes, then mean absolute error, and yeah, okay, cool. So we can do it in this way. Wait, this is weird. So when I type when I put one single quote, it doesn't complete it, right? But when I put another to complete that, then it adds two. So okay, fine. I guess this is a way to do it then, because maybe it's expecting something after that F apostrophe. I'm not sure, but okay. Max leaf nodes, and then in here we want to put in max leaf nodes. Then we give four tabs, I guess, and then we say mean absolute error, and then we pass in our May. Okay, I should be able to run this here directly. Let me just activate the environment. Right. Python py01 dot py. Give it a second because it's running multiple of these models, so it's going to take a bit. Okay, there is our result. Also, I guess I didn't need those extra tabs. Yeah, cool. Oh, also now it's running a lot faster. I wonder if the other thing was just sort of like a warm up. That's interesting. Okay, cool. Great. Of the options listed, 500 is the optimal number of leaves. Oh, yeah, that's true because if you look, it is, hold on, here. If you look here, so on the first with 5 nodes, we have this kind of value, which is close to 350,000. So in error, it's close to 350,000. Then it goes down to 258,000. Then it goes down to 246,000, right? That's at 500 max leaf nodes. And then when we increase the max leaf nodes to 5,000 from 500, then the error actually increases. It doesn't decrease. Okay, conclusion. Here's the takeaway. Models can suffer from either overfitting or underfitting. Overfitting is capturing spurious, I'm not sure how to say this word, spurious. Let's say spurious. Capturing spurious patterns that that won't recur in the future. Hold on, this is too small for me to read here. Let me read it off of this. Yeah, capturing spurious patterns that won't recur in the future, leading to less accurate predictions. Wait, capturing spurious patterns that won't recur in the future. Oh, so it's capturing patterns that won't recur in the future. Because of that, it's not able to generalize very well when other patterns do appear, leading to less accurate predictions, or underfitting, which is failing to capture relevant patterns, again, leading to less accurate predictions. We use validation data, which isn't used in model training, to measure a candidate model's accuracy. This lets us try many candidate models and keep the best one. All right, now we are ready to move on to the exercise. Oh, I clicked on the wrong one. It's supposed to be this one. Right. Give this a second to finish doing its thing because it's going to take some time to load. In the meantime, I think there was a conversation that I was having with Gemini about actually, okay, yeah, there was I was reading up on like Docker and Linux containers, and that was an interesting conversation to read. That was interesting information to read. I definitely think I'm gonna be using that at some point in the future, for very specialized reasons though. Not as part of my regular workflow, but there might be situations where it might be part of my regular workflow, especially if certain applications insist that you only use a Docker container, maybe because they have dependencies that they need to install, which could very well conflict with the other dependencies that are installed on the system. But yeah, yeah, Oh, you know what? This is an interesting one. While this notebook is loading, I was doing some research on. Well, it wasn't really research. It was a simple question that I'd asked Gemini. It was like, what was the question? Okay. Let me read out the question that I'd written. This was specifically related to the matrix rain thing because I was trying to get a better understanding of exactly what it was meant to represent. Because like it's a cool looking effect, and it's a, if anything, it's more of a nostalgic effect. I feel like a lot of the aesthetic appeal of it comes from that nostalgia. But in general, also it just looks like a cool effect. But I was curious about what this is meant to represent exactly. So okay, here's what I asked. Here's the prompt that I gave. You remember the Matrix rain effect from the movie The Matrix? Well, that has been reproduced using languages like C and Rust over the years. I'm using the Rust version called Rusty Rain. What I'm wondering is, what exactly is the Matrix Rain supposed to represent? Even in the movie, for that matter, what exactly is the Matrix Rain supposed to represent? What are we supposed to be taking away from it? What are we supposed to understand is happening? And this is the response that I got. That's a great question that gets to the heart of the movie's theme. The Matrix Rain, or digital rain, represents the raw, unfiltered code of the Matrix itself. Here's a breakdown of what it signifies. The nature of reality. The rain is a constant visual reminder that the world the characters inhabit is not real. It's a computer simulation. What they perceive as buildings, people, and the sky is all just code, represented by the falling green characters. Okay? Seeing beyond the illusion. For most people inside the matrix, the code is invisible. Just a second. This notebook is taking some time to load. Uh, okay. I don't know if this is gonna remain. I don't know if this is about to freeze now. Give me a second. Let me stop it and then try to. Actually, let me try to open this again. Let's see if it loads properly this time. Okay. So, seeing beyond the illusion. For most people inside the matrix, the code is invisible. They only see the reality it generates. However, operators on hovercrafts in the real world and gifted individuals like Neo can see this code. When Neo starts to see the world as digital rain instead of physical objects, it signifies his awakening and his ability to manipulate the rules of the simulation. Then, complexity and control. The sheer density and speed of the follow the sheer density and speed of the falling code illustrate the immense complexity of the matrix program. It's a visual metaphor for the all-encompassing system that has trapped humanity. In essence, when you see the matrix rain, you are supposed to understand that you are looking at the fundamental building blocks of an artificial world. It's the source code of reality, and the ability to perceive it is the first step to breaking free from its control. That's crazy. That's crazy. Hell yeah, dude. Okay, cool. I guess I can close this now, or I can. Well, yeah. Let's quit it. I can open it up again if need be. Okay. So this is awkward because I don't think this exercise this notebook is gonna load. I feel like my browser I feel like my browser is about to crash. My browser is gonna freeze. It's going into that state where it's just not gonna respond. Everything else is working, but like it's just working. Um, what do I do here? Give me a second. Let me see if there's anything else that I can do with the browser. If it allows me to do anything else. All right, I'm able to open a new tab. Let's see if anything loads in the new tab. Yeah, it doesn't seem to be responding, which is unfortunate, dude, because this means that if I want to continue, then I'm going to have to restart my system. Hold on, let me see if there's a way for me to like force this thing to. Let's see if like a Google search or something works. If something snaps it out of whatever is going on right now. Yeah, you know what? I think waiting is just gonna waste time. So what I'm gonna do is I'm gonna end the stream. I'm gonna restart my machine, and then restart the stream. It's unfortunate, but it is what it is. Hopefully, I should be able to stream for a little longer after restarting the stream, but let's see. So yeah, I will see you guys in maybe. Uh, the bad part is that it takes time for the system to restart as well, restart and then stabilize. So I'm not going to be able to start the stream for at least another like 15 minutes. But yeah, that's it is what it is. So yeah, I will end the stream and I will restart my machine and then restart everything else and then restart the stream after that. So